I am Vinayak. So I am presenting about our COA topics like static memory and dynamic memory. In static memory, mm, starting introduction. The introduction about our topic like this. The main memory is also uh, called as a random. The main memory is a volatile memory used by CPU to store data and instructions temporarily during the execution time. As the main memory, also called as a RAM, random access memory, is a volatile memory used by CPU. Temporarily storage data and instructions that are currently needed while a program is running. RAM is very important because it provides a faster read and write access to CPU, and faster RAM directly improves the overall system performance. Program execution faster when the data is available in the RAM instead of secondary storage. Since the RAM is volatile, all is lost when the power is switched off. Because of based on storage method and the timing, RAM is broadly classified into static memory, that is SRM, and dynamic memory, that is DRM. In DRM, again, we classify into two types: synchronous and asynchronous. This classifier helps to choosing the memory based on speed, cost, and applications. Next slide. Uh, about static memory. Static memory stores the data using flip-flops. As long as power is supplied, data remains stable without refresh. Static RAM, static RAM, SRM. As long as power is supplied, the storage data remains stable, and so no refresh operation is required. The working principle: each bit of the data is stored using a six transistor, 60 cell. It consists of two cross-compiled inverters that continuously hold the logics 0 and 1. Two axis transistor allow reading and writing the data. Since the data does not leak, refresh cycle are not needed. And characteristics are like very high speed compared to the DRM, low density, take more space per bit, high power consumption due to the continuous operation, compensative, so it is not used a large memory size. SRM is preferred where speed is more important than cost. Next slide. Yeah. Mm. The explanation about diagram. The in diagram shows a 60 SRM cell, and the WL word line controls the access to the cell, and PL and BLB bit lines are used to read and write the data. Transistor maintain data using a feedback, ensuring stable storage. Applications: SRM is mainly used in CPU cache memory L1, L2, L3 for very fast access. Register file inside the processor. Buffer is high speed system. Advantages: faster type of RAM available. No refresh is required. Unlike DRM, highly reliable and critical operation. Due to high cost, SRM is used in a small size but high speed areas of a computer. So next, my friend Naveen will present the for other presentation. Thank you.
Hello guys, myself Nandish. I am here to explain the dynamic RAM. Dynamic RAM stores each bit as electric charge in a capacitor. The working principle, each cell consists of one transistor and one capacitor. Capacitor leaks charge, periodic refresh needed. Data is dynamic, not permanent. Which means in a dynamic RAM, each cell of data consists of a single transistor and a capacitor. Capacitors leak charge, which means capacitors have a natural tendency to leak the charge. So the computer need to periodically refresh the RAM. Data is dynamic, not permanent. As we know, RAM is a non-volatile memory. Sorry, volatile memory. So it's not a permanent. The characteristics of a dynamic RAM. It is high density, which means in a small amount, in a small area, physical area, a large amount of data can be stored. It is lower cost compared to static RAM, slower than static RAM, needs refresh cycles. Applications, main system memory, graphics memory. Advantages of DRAM: large storage capacity and cheaper per bit. Thank you.
Good evening everyone. I am Naveen. Today my topic is asynchronous DRAM. Means it is a type of dynamic RAM that does not work with the system clock. Memory operations happen based on control signals, not clock pulse. Means here asynchronous DRAM is the earliest from a DRAM that operates independently of the system clock. Means a DRAM was the first DRAM technology developed and it does not depend on CPU clock timing and the memory response whenever control signals are activated. And the working principle are controlled by signals like ADRAM operations are controlled using hardware control signals, not a clock. And here we have a RAS means row address store means it is a signal is used to select the row address in the memory. And when RAS is activated, the row number is latched means it will store temporarily and it will tell memory which row of shell to access. And we have CIS means column address trove means CIS signal is used to select the column address after the row is selected by RAS. CIS selects the column within that row. Together, RAS and CIS identify the exact memory location. And we have CPU must wait for memory response. Here, since there is no clock synchronization, the CPU can't predict when data will be ready. The CPU waits until the memory finishes the operation, means it will increase the delay. Next, we have no synchronization will clock, means AD RAM is not synchronized with the clock, and the timing depends only on signal delays, making it slower. And we have the characteristics. First, we have slower access time, means memory access is slower compared to modern RAM like SD RAM. CPU waiting increases totally execution time. And next we have simple design. Means it is a circuit structure is easy to design and implement, and it will requires the fewer control mechanisms. And we have the high latency. High latency means delay before data transfer starts. And asynchronous DRAM has higher latency due to waiting and lack of clock sync. And there is a two types of DRAM. First, fast page mode FPM DRAM means it will improve performance by keeping the row active while accessing multiple columns. And it is faster than the basic DRAM, but still outdated. And second type is extended data out EDO means DRAM. Improvement over FPM DRM keeps data available longer on the output pins, slightly faster than FPM DRAM. And next slide we have the diagram. In diagram we know there is a address line A0 to A20. It will carry address information, and we have the row address latch means it will store row address when RAS is active. And we also have their identifying row decoder means it will activate the selected row in memory array. And we have their memory shell array means it will store data bits means like shown as 4096 into 512 into 8. After we have sense or write circuit means it will sense data during read, write data during write operation. After we have column address latch means it will store the column address when CIS is active. Column decoder means it will select the column inside the active row. And we have the CS means chip select enables the memory chip. After last we have the RRW means read or write. It will determine the read or write operation. And applications we have world computers, Pentium era system like ADRAM was commonly used in early PCs like Intel Pentium systems, and replaced later by SDRAM due to performance limits. And and advantages we have simple architecture means it is easy to design and control, and a less complex hardware. After we have the low cost means it is a cheaper to manufacture, and it is suitable for early and low performance system. Thank you.
So good evening everyone. Today I am going to explain synchronous DRM, commonly known as SDRAM. SDRAM is a type of dynamic random access memory that works in synchronization with the system clock. Because it follows the system clock, the communication between the CPU and memory becomes faster. This synchronization improves performance, speed, and efficiency when compared to older memory types. And the second one is principles of SDRAM. Uh, in SDRAM, all memory operations are aligned with the CPU clock. This means read and write operation happens at a fixed interval. So SDRAM supports pipelining, which allows only one operation to start before the previous one finishes. Because of this, SDRAM can perform multiple operations in one clock cycle. This reduces delay and increases the overall speed of the system. And coming to characteristics of SDRAM, first SDRAM is faster than asynchronous DRM. So second, it supports burst mode data transfer, where multiple data bits are transferred continuously without interruption. This burst mode improves bandwidth utilization, meaning the memory is used more efficiently because of these features. SDRAM provides better performance for modern systems. So there are some types of SDRAM, which are called the types of SDRAM. The first one is SDRAM, which transfer data once per clock cycle, and next is DDR SDRAM, which transfer data twice per clock cycle. After we have DDR2, DDR3, and DDR4, and up to DDR5. Each newer version offers higher speed, lower power consumption, and better efficiency than the previous one. So today in modern computers, mostly use DDR4 and DDR5 memory. And coming to next slide diagram, it includes in this diagram, internal block diagram, it includes rows and column address latches, which select memory location. The row column decoders help to accessing the correct memory cell, and the cell array stores the actual data. And the read and write circuits handle data operations, and input and output registers manage data transfer. All these components work together, are controlled by the system clock. And the application of SDRAM are SDRAM is widely used in modern PCs, laptops, and servers. It is also used in graphic cards, and very fast memory access is required. So because of its high speed, SDRAM is suitable for performance-oriented systems. The advantages of SDRAM are it offers high speed compared to older memory types. It provides better coordination between CPU and memory, and also it supports efficient and fast data transfer and improves system performance. And the conclusion part is the last part. To conclude, SDRAM is the fastest memory, but it is costlier and has low capacity. So it is used for cache memory, and DRAM is cheaper and provides higher capacity, but it needs refreshing. So asynchronous DRAM is slower because it does not use clock synchronization, and synchronous DRAM, on the other hand, works with the system clock, giving higher speed and better performance. Therefore, SDRAM is widely used in modern computers. Thank you.